Hello and welcome back. In this video we will walk through a straightforward Python program. In the beginning I will give you an overview of what I plan to cover, then I will switch over to Python idle editor, walk you through the script and then run the program in Python shell. At the end, if you've enjoyed this video, please consider liking, sharing and subscribing. Now let's begin. For this Python program, the purpose is to provide an example of the while loop using an accumulator variable. We will develop a program that calculates simple compound interest on an investment. The repetition structure specifies that a block of statements be executed repeatedly based on a given condition. The statements and the process block of code are executed several times, so this structure is often called a loop structure. A program segment that includes the repetition structure has three major parts and its form. 1. The initial conditions. 2. The steps that are to be repeated, and 3. The final results. There are three general forms of the repetition structure: the while loop, the repeat until loop, and the for loop. The first form of the repetition structure, the while construct, is the most flexible. The other two forms of the repetition structure can be expressed with the while construct. The while loop consists of a conditional expression and block of statements. This construct evaluates the condition before the process block of statements is executed. If the condition is true, the statements and the block are executed. This repeats while the condition evaluates to true. When the condition evaluates to false, the loop terminates. The actions in the process block are performed while the condition is true. After the actions in the process block are performed, the condition is again evaluated, and the actions are again performed if the condition is still true, otherwise, it terminates. The condition is tested first, and then the process block is performed. If this condition is initially false, the actions in the block are not performed. The number of times that the loop is performed is normally a finite number. A well-defined loop will eventually terminate, unless it has been specified as a non-terminating loop. The condition is also known as the loop condition, and it determines when the loop terminates. A non-terminating loop is defined in special cases and will repeat the actions forever. In the while loop construct, the condition is tested first and then the statements in the loop block are performed. If this condition is initially false, the statements are not performed. The number of times that the loop is performed is normally a finite integer value. For this condition will eventually be evaluated to false, that is, the loop will terminate. This condition is often known as the loop condition, and it determines when the loop terminates. Only in some very special cases, the programmer can decide to write an infinite loop. This will repeat the statements in the repeat loop forever. A counter variable stores the number of times, also known as the iterations, the loop executes. The counter variable is increment every time the statements in the loop are performed. The variable must be initialized to a given value, typically to 0 or 1. The first time the statements in the block are performed, the loop counter variable starts with a value equal to 1. The second time through the loop, the variable has a value equal to 2. The third time through the loop, it has a value of 3, and so on. Eventually, the counter variable will have a value equal to the value of the maximum number and the loop will terminate. An accumulator variable stores partial results of repeated calculations. The initial value of an accumulator variable is normally set to 0. In programming, each counter and accumulator variable serves a specific purpose and these variables should be well documented. The goal of this program is to determine how much your money can grow using the power of compound interest. Compound interest, also known as compounding interest, is the interest on a loan or deposit calculated based on both the initial principal and the accumulated interest from previous periods. The rate at which compound interest accrues depends on the frequency of compounding. The higher the number of compounding periods, the greater the compound interest. Now, let's open up the Python idle editor and develop a program that calculates simple compound interest on an investment. First, start out by putting identification information for the Python file enclosed by 3 quotations. For the program file name, let's title it while accumulator.py. Then the author information, and for that, I'll put my name Lewis. Next the date, which is August 16, 2022, and lastly I'll put a short description of the program. This program calculates compound interest using the while loop accumulator variable construct for a small investment. First, let's create the input statements for each variable associated with calculating compound interest. The variables are principal, additional payments, rate, and time. Start out by typing principal equals and open parenthesis, input, open parenthesis, quotation, then the statement enter initial investment amount, colon, close quotation, close the parenthesis twice as there are two preceding opening parentheses, then press enter. The principal is the initial amount you borrow or invest. The input statement reads a value of a variable from the input device, in this case, the keyboard. This will display the string literal enter initial investment amount. Since the number to be input is an integer, therefore we define the data type as int. The data type int, for integer, is a whole number, positive or negative, without decimals of unlimited length. Next, type additional underscore payment equals int open parenthesis, input, open parenthesis, quotation, then the statement enter additional annual contribution, colon, close quotation, close the parenthesis twice as there are two preceding opening parentheses, then press enter. The additional payment amount corresponds to additional deposits on top of the initial investment throughout the year. Next, type rate equals float open parenthesis, input, open parenthesis, quotation, then the statement enter interest rate, colon, close quotation, close the parenthesis twice as there are two preceding opening parentheses, then press enter. The rate is the annual rate of interest. The keyword float will take input values and convert the specified values into a floating point number. Next, type time equals int, open parenthesis, input, open parenthesis, quotation, then the statement enter number of years, colon, close quotation, close the parenthesis twice as there are two preceding opening parentheses, then press enter. The time corresponds to the number of years the amount is deposited or invested. Now, we have to translate the rate into the real rate by typing real underscore rate equals rate multiplied by 0.01. Next, let's define our counter variable prior to creating the while statement. Let's set the letter I equal to 0 by typing I equals 0 and press enter. This will allow us to keep track and report the ending balance of the principal amount at the end of each year. Next, let's create a print statement prior to showing the ending balances of our investment at the end of each year. Type print, open parenthesis, quotation, then the statement, below is the ending balance for each year throughout the life of the amount you invested, close quotation, close parenthesis, and press enter. The print statement is used for the output of variables and text strings. These output statements write the value of one or more variables to the output device. Now we can work on the while construct. Type while I less than time, colon, and press enter. This essentially tells Python to perform the loop while the counter is less than the time of year's input. Next, let's create the formula for the principal amount to be calculated each year. Since interest is compounded annually, type principal equals, open parenthesis, principal plus additional underscore payment, close parenthesis, multiplied by open parenthesis, 1 plus real underscore rate, close the parenthesis and press enter. Now, we have to define our counter variable further. If you recall from earlier, I want Python to output the ending balance of the investment at the end of each year. Therefore, we need to keep track of the years and amounts accumulated. Type I plus equals 1 and press enter. For every year throughout the life of the investment, Python will print the ending balance. Next, let's print the principal amount calculated throughout the life of the investment. Type print, open parenthesis, the letter F, quotation, then year, open curly bracket, I, close curly bracket, colon, close quotation, comma. I want to round the result to 2 decimal places. This is accomplished by using the round function. Therefore, after the comma, type the word round, open parenthesis, principal, comma, 2, and close the parenthesis twice as there are 2 preceding opening parentheses. The F preceding the print statement means formatted string literals, and it's new in Python 3.6. It is a way to format your string that is more readable and fast. The I, enclosed in curly brackets, is our counter variable. This will allow Python to show the year number when the program is executed. The round function returns a floating point number that is a rounded version of the specified number, with the specified number of decimal places. Now, let's run the module and confirm our while accumulator loop counter for calculating compound interest is executing as expected. In the Python idle editor header, click Run, then click Run Module. After the idle shell opens, let's input 1,000 as our initial investment amount, 150 for our additional annual contribution, 6.8 for our interest rate, and 10 for the amount of years. As you can see, based on the code we input, Python calculated the ending balance for each year over the life of the principal investment. So for this example, if we invested $1,000 plus $150 annually at 6.8% over 10 years, we would have accumulated $4,123.29. Thank you for watching my video. If you've enjoyed this video and found it informative, please consider liking, sharing, and subscribing. Please hit the notification bell so you'll be notified when I upload videos to YouTube. I'll see you next week with a new Python video. Until next time, take care.